A toy car stops from rest and accelerates. Then it maintains uniform speed, and finally it decelerates to rest. We actually have to split this problem into three parts. And because I'm feeling sassy, we're going to use three colors. And the thing I don't want to hear is like how my choice of colors really clashed badly, or how like they just don't go well together. I don't need that kind of negativity in my life. Okay, so just deal. Thank you. All right, so here we go. First, for the first part, I'll say x naught is 0, x is unknown. We have a time of 3 seconds and an acceleration of 4 meters per second squared. V naught is 0, and V at the end of the first leg is also unknown. So what I'm going to do at each leg of the trip is solve for all of the unknowns. So I will actually say x is 1/2 at squared plus v naught t plus x naught, just to see how far it goes. So x is going to be 1/2 times 4 times 9, because it's 3 squared, plus 0 plus 0. So it looks like we cover 18 meters in the first leg. And just for the heck of it, I'm going to also get the speed as well. So v equals at plus v naught, and that's going to be 4 times 3 plus 0. That ends up being 12 meters per second. Now it maintains a uniform speed for 12 more seconds. What that means is we can actually use the Buggy Lab formula. So I will say that this x naught here, so the x here is the x naught. I'll call that 0. And then v naught is going to be the v from previously, which I got as 12 meters per second down here. And we also know that we don't know what x at the end is. We don't need a final v. We need to know that the t is 12 seconds because we're going to use the Buggy Lab formula. So for leg 2, we can simply say x is v naught t plus x naught. That's going to be x is 12 times 12 plus 0. Excuse me, and we get 144 meters. That's cool. Now for the last part of this, let's be clear. We end up having a x naught will set equal to 0. Now v naught is equal to 12 meters per second. V final is 0 because it comes to a stop. We don't know what x is. We know the acceleration is unknown, actually. Don't assume it's 4. And we know the time to stop is 2 seconds. So let's solve for what we can solve for. We want the total distance traveled. Let's see what we can do with this. So we could say x is 1/2 at squared plus v naught t plus x naught. So x is 1/2 a times 2 squared plus v naught, which is 12 times t plus 0. Uh-oh, not a good formula. So let's try the next one. Let's try v equals at plus v naught and see what we can solve for. So we have 0 is a times the 6 seconds. Sorry, that should be 6 there, and that should be 6 there. A times 6 plus this speed of 12, and a ends up being -2 meters per second squared. Aha. Now let's see what we can do with this. Maybe we can plug it back in this first one here. So let's try it. X is 1/2 times -2 times 6 squared plus 12 times 6. So this ends up being -36 plus 72. That gives me an additional 36 meters. So the total distance is going to be 18 plus 144 plus 36, which ends up being 198 meters. Now the average speed, this is something you wouldn't have known, but you take the distance over the time, and that's going to be 198 divided by the total time, which is 3 plus 12 plus 6. 198 divided by 21, and we'll see what we get. Okay, so I'm getting 9.4 meters per second. Awesome, so that's the average speed. All right, so that's it for problem number 3, and we'll continue in the next video.